right, I got a good question. Let's see. So we're gonna test some of your string processing abilities.
Okay.
Let's see how you perform. So this is the first question. So I just want you to write a function that takes a string containing only lowercase letters and returns the length of the longest substring that contains the same character. So here the longest substring is B's, and that's a length of 3. This one all characters are different, so it's just 1. And here all characters are the same, which is 5. So write me a function with this function signature that is able
Okay.
to do that.
So I guess I'll start with trying to understand Rob. So I guess we're trying to find a substring, the longest
Yep.
substring, given a string, right?
Yep.
And can the string be empty, or is it
Yep.
always at least one?
Yep. It can be empty.
Okay. So in the empty case, would it just return nothing? Would it
Yep.
return none,
0.
or like
Return
empty
0.
string? Okay. Okay. Then I guess looking at this, then I guess I could write some test cases, I guess, too. So I just say given
What keyboard you have? Sounds good.
MQ80. So if we're looking at this test case, we could see like there's two substrings here, right? That would continue. Like, yeah, that would continue. I actually put an extra, and then we choose the longest out of this. Let's say
Exactly.
this is length 2 and this is length 3. So then our return type here would be 3, right? Or is it? Oh, I guess it would be B, I guess, right? Okay, so looking at this problem, since we're counting like I guess we're kind of we're trying to find the substring. So I guess we could first maybe convert the string into a list for easier manipulation.
Well, we just need to return the length of the longest substring, not the actual substring.
Oh yeah, the language, yeah, 3. Um, so okay, so if all characters are different, we could return 1. Hmm. Okay, so I'm thinking we could maybe do a linear scan
Sure.
of the string. So let's say we start here, right? We start here, and we're gonna check if the next element or the next string is the same as this current one. If it is, then we could say then we can update the frequency of that string. If it's not, then we go back to 0 and we make this our new substring.
Okay.
Okay, so I think is there anything else I need to cover? I guess yeah, another edge case. Be all different would be 1, right? So I guess we could start at the beginning. Actually, I think we could. Actually, that doesn't work either. I guess we could start at the beginning. So let's see. See, I'm trying to think of like a way to, I guess, store the substrings, like the length of the substrings. I guess we could maybe make use of a hash map to store each subsequence and the substring is, I mean, the length of the substring associated with it. Then I guess find the max. That works.
Well, we just need to return the longest sequence.
Yeah, we're trying to return like the number, right?
Yeah. So we don't really care about any other sequence.
Oh yeah, okay, yeah. Okay, so yeah, so base. I'm trying to think how I could like store the substring when, because you could find like the first sequence, right? Then you know the count of the first sequence, but then let's say you find the second sequence, you also need to know the count of that. That's why I thought maybe you could use like a hash map to like just store the sequences itself.
I mean, you could, if you want to.
Um,
What would be the trade off?
using for using like the hash map, I guess more
Yep.
memory.
Yep.
Like I guess it'll be O of n for memory.
Mm-hmm.
Hmm. But I know there's definitely an approach well hash map. Okay, I
I
guess
mean,
actually before writing this code, I'm gonna just like write out like a better plan for this. Um. Okay, so yeah, I think I would, I guess, can create like a stack, and inside the stack, I'm gonna store like a tuple, I guess. And I guess the first tuple value will be the substring, and the actually the first tuple value, actually I just could create a stack and just store the.
create a stack.
Oh
Here,
wait, what am I?
just do the hash map, and then we'll
I
just
could
work
just do
from
the
there.
hash map.
Just do the hash map.
Okay. I guess we could have like a running count. So we first check. Oh wait, start here. Actually, yeah, I think we start at the first index. Then I guess you could look backwards and see if it's the same. If it's the same, you could update the running count because that's another frequency. And so So if the current string is the same as the previous one, you could say the running count plus 1. Else, if it's different, we could update the current string at this time. And now we have to figure out like a way to oh wait, okay. Okay, yeah, okay. So we have to have like a max counter, right? Our current like max. Then let's say else if the running count is greater than our current max. We could say the current max is now our running count. And here, the other case that we need to make sure is that if it's different, right, we want to reset the running count back to 1. I mean, back to 0. And we also want to update our current string to be the string we're on. So okay, so I think I need to do like a quick like dry run of this.
Yep.
So just put it here. So we have current max, running count. String. So let's just use this first test case, I guess. So we start at okay, yeah. So this is the for loop, right? So we start at index 1, right? So start at index 1, which would be like A, and then we set this.
One tip is you could just do something like this to show where the index
Oh,
is.
okay.
To just make it easier.
Yeah. Okay, yeah. So we start there, then we look back. We look back and say, oh, A is the same as this one, right? So we update the running count to 1. Well, I guess we always want to start the count at 1 because it indicates it's the current one we're on, so the count will always be 1 for that one. So we start at 1 here, then we look back, okay, it's 2. Then hold up. Then it's 2 here, then we look to the next one. Oh yeah, we also have to update the current max to 2 now. We'll look back to the next one. Since it's different from A. Oh wait. Yeah, since it's different from A, we set the our current string to be B, and we also have to reset the running count again to 1. Then yeah, we keep looking to the next one. So if this becomes 1 and we move to the next one becomes 2, right? Then we look there. Then and we look behind. 2. Then the last one's here. Yes. Oh, I guess I forget to add the very last index, I think. There. So it should be there. Is there anything I'm missing here?
But then we just had AA. What would yours return?
Oh, I guess you would just return to.
Based on your algorithm?
Oh, based on, let me see. We start here. I guess I think. Yeah. So we get index 1, parent back, running count 1. Oh, I guess we'll just end. Right.
And yeah, we end with what? What would be the max there?
It would just be 1. I
What is
think,
the
right?
answer? Yeah.
It's supposed to be 2.
Okay.
It's
Pretty
because
fix it.
it never gets I guess updated. Oh, I get. Wait. Oh, I guess no. You want to basically check at the end.
Let's
Yeah,
see.
yeah,
No,
because the
that's
last
not gonna
thing.
work. Or that doesn't change anything, really. Because even your last, like the last iteration will always hit this, so this is kind of the same. Like your last iteration will go, it'll
Oh, was
update
it?
the current count, and then it'll update the max. So it's not because of this. It's a different reason. Try dry running it.
Okay, okay. So look back here. Oh, I guess yeah. I didn't add the because
You
when you set the
you
new
do
one,
have
you
the
want
running
to
count there.
do I? Oh,
Yeah. You already handled that case. If it's not the
okay.
same, you set it to 1. Try dry running it.
Yeah. Okay. So you start at you guys index 1 here, right? Then the current string is A. Then I guess our current running count would also be 1 here, right?
Well, it
Then
starts at
oh, okay.
0, right? Starts at 0.
Yeah,
Okay.
it starts at 0. Got ahead of myself, but yeah. Okay, then let's say during the first iteration we get the current string and then we hit the first if statement. Since they're just same, yeah, this code is actually like really not well maintained.
No, it's good. It's good.
Let me,
It's fine.
okay,
You don't
I
need
was
that.
just gonna
Okay.
fix it. I was just gonna refactor it, but okay. So yeah, our running count. We're at index 1, so here, then our running count here becomes 1 here, then since the running count is greater than our max, since greater than our max is 1, but then the code just ends and doesn't add like the itself, I guess.
Well, it did add itself.
Well, it doesn't add like the previous one, right? So can I? Yeah, is that instead of comparing it? Actually, would that work?
Okay, I'll give a hint. It's the way you initialize the variables.
The way I initialized.
You could fix it if you initialize the variables in a different way.
Oh, like 1 here.
Yeah, because you're counting the first
Yeah.
character as already a substring.
Yeah. Oh, okay. Yeah. Because when we look back, we add 1. Yeah.
Okay, let me ask. Okay, I think it's good. Run it on a few test cases. Like just in the
like
code.
wait, like dry run.
In the code, just run it and just ensure it works.
Okay, that's no. Oh, let me print. Okay, yeah. Okay, that works.
Nice.
Okay, yeah. I'm just kind of nervous right now.
No problem. And then
Yeah.
you can't do tree. Can you do trees at all?
A little bit. I'm better with like linked lists or like
Okay. Let's see.
I'll say my tree skill is probably around the same with like grass right now.
Hmm. Let's see.
We given price array.
So yeah, this is the second question. I'll quickly read it out. You're going to be given an array of prices where the price of I is the price of a stock at a given day. So the ith index is the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Tell me what's the maximum profit we could achieve based on the prices. So I'll post in some examples.
Okay. Okay, so let me just. Okay, so looking at this, we're choosing a time to buy stock, right? Like it could be any time frame.
Yeah.
Then I guess we're selling it at a future date.
Yeah.
And we want to maximize this profit. And I guess we're given array of prices. And the array is never empty, right? Or can it be?
Well, it could be empty.
Okay. And if it's empty, what would you return? Like 0? or like
Yeah.
just nothing, or just
0.
none. Okay, return
0.
0.
The
Okay.
maximum profit is $0. You can't make anything.
Okay. So I guess I could write some examples first. I guess, like work through some examples. I'll just take the first one.
Yeah. Makes sense?
Yeah. So I guess if we have 7, right? So if we start with 7, and then we keep looking, and I guess we try to find the maximum price, which is I guess 6. So I guess 6 minus 7 1, well -1. So we're losing money there. Then I guess we try the next value, and we look for the. Oh, I guess we look. Oh wait, I guess yeah. Look for the next I guess maximum, which is 6. Oh, actually, it should be the other way around, I think, right? Because max profit would be 5 here because we bought it at 1 and we sell it, so this should be flop too. So we're actually losing money here, and then I guess if we're at 5, the amount we're buying it for, then and we could only purchase it in future dates, right? We can't like go backwards.
Yeah.
Okay, yeah. Purchase it at 5. It'll also be 6. And then I guess we purchase it at 3. Also, yeah, I guess these are all 6s. Just a 4. Oh wait, I missed. Wait, can you sell it on the same day you bought it?
No. Well, if you sell it on the same day you buy it, you don't make anything.
Yeah, you don't make anything. So I guess I'll skip to I guess 4. Then
Why are you comparing 6 with like 5?
like this.
Oh, okay. Oh, you
Because if we bought it when the price was 5, right, and we sell it when 6, the profit's 1,
yeah.
right?
Makes sense.
And then, oh, I mistyped here. This was supposed to be a 6, right? We bought it at 6, and we can only sell it at 4 because, well, I guess that'll be a negative profit, but okay. So looking at this, I guess you could do like I guess one solution would be like maybe brute forcing. You'll try like every single combination, and you will like, for example, you start 7, then you try to find the max of the rest of the array, then you find the difference.
Sure.
But I think there's probably like a more optimal solution for this.
What would be your runtime there?
N squared, because you're going over it twice, basically. Well, you're going over n squared time, basically. I guess I could start planning. So yeah, that was like brute force, but let's see. Let me think if there's a faster solution to it. Okay, actually, I'm gonna just start writing the brute force and see if I could come up with a more optimal on the way.
So what's the bottleneck with the brute force?
It's Oh, is it in the constraints?
Or what when you think about the brute force solution, what makes it so slow?
Because I guess you have to like recompute, right?
Recompute what?
Like you have to check. Well, I guess what makes it so slow, because you're trying like every single combination. You're doing more than like a one pass solution.
Yeah. But like for each element, what's the bottleneck?
You have to find like the a future date, I guess. That
That is the maximum, right?
Yeah, that is maximum. Yeah.
How can we speed that up?
Hmm. I guess can we keep storing? Um. Can we first try to see? Wait. Yeah. Um. Let's see. If we start at 7, then we go next.
Because the bottleneck is for 7, we need to know to my right who's the
Mm-hmm.
largest. Then for 1, to
Yeah.
my right, and it's taking O-Ven to go find into your right.
Yeah.
So is there a way to speed that up? Maybe know right away. Oh, my right, the largest is this.
I guess can we keep? Hmm. Can we like keep storing like something with like the minimum price? Like we want to find. I think we want to find like which one will have the minimum price. So we start at 1. Or actually, can we find? So let's say we're at 7. Then if we just compute this side once and find the maximum, then oh wait, that wouldn't work either. You have like a hint.
Yeah. Let's see. Okay, try to flip it in a different way. Flip it as in maybe for each element try to sell. So for each element try to sell, and
Mhm.
if we're trying to sell, right? Then we just need what do we need to know to the left, not the right? Like because right now you're trying to buy and then see
Oh,
where you can
oh,
sell, but
oh.
try to sell at each.
So like you go backwards and you're trying to find you find the
Okay.
minimum,
Or I'll give
right?
you the hint would just be try selling at all times.
Try selling at all times.
Like instead of thinking about where to buy, think about it as where am I gonna sell? Or if I sell here, what would be the result? You can move from left to right.
Okay. Wait, so I'm
Because
supposed to be
if
moving left to right?
you yeah, well, because if you're looking to sell and then you're moving
Yeah.
from right to left, then it's still the same problem where you need to look into the future.
Mm-hmm.
What you're trying to avoid here is having to look into the future or being able to look into the future fast. So, for example,
Oh wait,
try
can
selling
we do?
here, try selling here, try selling here.
Oh wait, can we just keep a counter then of the current min and current max? Then we just do a single pass through it.
How would that look?
So, okay, I guess I will start writing the code.
Well, you
This
don't
is
need to, let's iron out the approach first before you write any
okay.
code.
Okay, so I guess we're gonna have like a counter thing, right? So let's say our max price 0 and our min price. So I guess we could first set our max price to be, I guess, the current index. Then I guess our minimum price, we're gonna compare if 7. Well, actually, this should be like an infinite number or something. So I guess I think it's like this, right?
We should just be 7 here too, because the minimum price we seen was 7, right?
Yeah, yeah. The minimum price would be 7, and the max price will also be. Wait, the minimum price would be 7.
Like, what
Oh
does the
yeah,
minimum
yeah. I
price?
mean, I was trying to do like a negative, actually. You do like a negative float. Oh, okay. I guess yeah. You're right. It should be like the same, right? Then we can go to the next one. You're looking at 1, and you're checking if 1 is less than 7. If it's less than 7, you could just set this to 1, right? But if it's greater than 7, you could set it to. I guess you could set it to. Yeah. So then I guess you keep looking until you find another that's has a higher price than it.
Here, try. This is getting closer, but you're still going in the wrong direction a bit. Like, try to sell at 7, sell at 1. Pretend I want to sell at 5. What do I need to
Mm-hmm.
know to my left if I want to sell at 5 to maximize?
The minimum price to the
Okay,
left.
if I try to sell at 3, what do I need to know to the left?
The minimum price to the left.
What about at 6?
The minimum price to the left.
Okay, and if I'm
Oh
moving
wait.
from left to right, will I know the minimum
Mm-hmm.
price?
Oh, okay. Oh, okay. So you want to track the current minimum price, then just subtract it with the current number you're on, I guess. Would that work? So I guess so you're doing like a I guess like a for loop through the whole thing, tracking the current minimum price, then also subtracting the current index you're on to the minimum price, and
Mm.
if that's greater than our like I guess max profit, then we could just set that to the new max profit and return the max profit at the end, right?
Yep.
We're given an array, right?
Yeah, we're given an array. We're given something like this.
the current. So I guess this should be set to, like, yeah. Right, we're checking if it's less than, then we could set the min price to be the current stock. And then we're gonna say max profit to the minimum price subtracted by, I guess, our current index. Oops. Oh, whoops! I actually closed the thing.
Where? Oh, okay. No problem.
Let me rejoin real quick.
Yeah.
Yeah. I actually hit like a keybind. Okay. Yeah. I guess that'll be our. Then I guess we could take the current max versus the at max. Then I think I'm still missing like some case here, I think.
You can try running it.
Alright, so let's just start with this. So we have 7. Let's see if we could like this. Yeah, so first index we start at 7. We check if it's less than the. Can I create? Yeah, we start at 7. Okay, so we say our minimum right now is 7. Then we go to the next one, and I guess we also our profit will still be 0 because 7 minus 0, 7 0. Then we go to the next one. Our memorize will be 1, right? Then we check the profit. We checked our minimum price. Oh, this should be flopped. Yeah.
Okay, try running it on all the test cases that I have up there. By just not dry run, just run the function. Create
Alright.
a function. Are you running Vim? Chat's asking.
Yeah, I'm running them.
Yeah.
Is there any other test case? Was it just 2?
Yeah, that's good enough.
Oh, I missed a bracket here. Five and 0. Okay.
Cool. All right. Yeah, that's pretty much it. How do you think you did? How was that for you?
Oh yeah, I was like, I was too nervous, but like I was thinking of the idea, but I just like kind of like I guess write it out in code. I guess.
Just it was just hard to implement. Let's see.
Oh, I would. Actually, I wouldn't say it was hard to implement. I was just like, I kept getting lost in my own thoughts. Just I
Yeah,
guess just 'cause nerves.
yeah.
Yeah,
No, it's fine.
yeah,
Cause okay,
yeah.
let me
That's why I'm here like practicing, right?
exactly. This is better to have the nerves right now than
Yeah,
when you actually
exactly.
do the real interview. So let's go through the feedback on question one. So I think you have a pretty good overall process of clarifying the question, discussing one or more working approaches, being able to write the code, dry run the code. You actually caught a bug during one of your dry runs,
Yeah,
so I think you have a good process. You clarify the question, yeah. You thoroughly think through the edge cases. You're writing them out, but then I think you're just having some trouble figuring out the maximum. So you talked about different approaches, like could we take the max? Like could we create a hash map of all of the different substrings and then take the result, and then but then you eventually came to this approach. So I think yeah, you eventually got there. But yeah, I just noticed in some of the questions you're having trouble finding the max or working with the max and minimum
yeah, yeah.
like having a maximum there. I think you could leverage the max and mins functions a lot more. For example, are you following my cursor?
Wait, how do I follow you?
Just
Okay, I see.
click on me in the bottom.
Oh yeah, yeah. I could set max here. Yeah, I
Yeah, you
see.
could just use max here, and then
Mhm.
even in this the second question, you can just calculate min here.
Oh yeah,
You're using
yeah,
max here, but yeah, just leverage the min and max, and then just return it.
yeah,
You eventually got there, but it took a bit to figure that out.
yeah,
And then yeah, you're having trouble with some of the edge cases. So with the running count, you starting equal to one took a little bit to
yeah,
figure it
yeah,
out, but yeah. So that's the main part I would just worry about is just having cleaner code by just using the min and max and just knowing how to capture the final result. Whenever you say minimum or maximum, this is a pretty common pattern of just storing sort of a current max like this, and then eventually returning that.
Oh, okay. Okay, so what
This
I did in this
it's a
approach.
pretty yeah. This is a pretty common. Whenever it says maximize and it's not some dynamic program or anything, you're
Yeah.
gonna have some sort of condition like that where you're maintaining a current global max and then you're eventually returning that. So just make sure you understand how to do that without using a hash map or a stack or anything like that,
Yeah.
by just using one variable. Second question. Yeah, second question you had a bit of trouble figuring out what would be the optimal solution. So I think for this one thing that you could also learn, you don't really need this for this question, but you should learn prefix sum pattern.
Mhm.
So it's basically when I asked you the question at first, when you're saying when I was like seven, right? How do you look
Yeah.
ahead to find the maximum? Or one, how do I look to my right to find the maximum? You could pre-compute. So understand that we could pre-compute. How would I pre-compute? Well, I can create a new array called to the left maybe, and then basically I could start from, or I can create a new array called largest, and then I can move from right to left, storing the largest that I seen. So four, what's the largest I seen here? Six. This is one way to pre-compute. You don't have to do this for this question, but understanding that this pattern exists. So you can see three. The largest I've seen to my right is six. I could just maintain a count or a max. Six. Six. You see what I'm doing there? Line 55.
Wait. Wait, can you go over that again?
So I can pre-compute the largest. I can pre-compute the largest to my right. So for
Yeah.
example, I move from right to left. Four is the largest, larger than anything to its right. Then we go to six. Six is the largest number we've seen
Oh, okay. I see.
right here. Six is the largest number we've seen anywhere to the even anywhere to the right.
Oh, so this ensures like every time we look to the right that we'll always get like the
No,
max.
this is like a separate data structure
Yeah,
that we
yeah.
store. So every time we look at prices, right, and we ask ourselves, what is the largest element to my right? We can reference this largest array to see, to like to
Yeah.
because we already pre-computed it, so we can cut down the time from O of n to O of 1. That's what I was asking. What is the bottleneck? How can we speed up that operation of looking to the right and finding the largest element? Like the way that we can
Okay, but
optimize that is pre-computing.
like you'll create like a separate data structure, right?
Yeah.
Of just the stack. Okay, but isn't this just more time or no?
Well, it's like this is
Because
this is
like
just one
even
solution. Your
yeah,
the
yeah.
solution you eventually got to was the optimal, but I'm just showing you
Okay, yeah.
other approaches that you could do. You need to understand how to solve questions in multiple different ways.
Hmm.
And this is just O of n. The only issue is just it just takes up more space. It
Yeah.
takes O of n to pre-compute the largest, and then O of n to eventually calculate the best price. Do you get this solution? This
Yeah, yeah,
alternative?
yeah. I get this solution. So you're basically just saying that if we're going to the prices with since we already have like a pre-computed table of the maximum, we could just always just look to the right of the largest of our current index, and that will be our max. And you just use that
Yeah, exactly.
to
So
find
when
the max profit. Yeah.
we look at 7, who's my largest to my right? I look here. Oh, the
Be
largest to my
six.
right is
Yeah.
6. Right. And then
Hmm.
pretend we're at 6, right? I ask the question, who's my largest to my right? It's 4. So at any
Hmm.
moment in O of 1 time, I could see who is the largest to my right. So that's just you don't need to do it for this question, but in general, you when I ask you, okay, how could we make something faster? You could think of pre-computing.
Yeah.
Yo, mods in the building. Yeah. Otherwise, yeah. I think for a sophomore, you're pretty good. But just continue to practice. I
Yeah.
don't think
Okay.
you have trouble coding at all. It's just getting to the right solution.
Yeah.
All right. Cool. All right. Good luck.
All right. Thank you.
All right. Catch you on. See ya.
See ya.